Hello everyone, I am Dr. Shailendra Kumar, Assistant Professor, Department of Electrical Engineering, Indian Institute of Technology, Bhilai. Today we are going to discuss introduction to EV charging station system. So, in this introduction to EV charging station systems, we are going to cover types of chargers, types of we can say EV charging system. So, under this content for this charging types of EV charging is as follows: introduction, current state of EV charging technologies, EV charging labels and modes. So, what are the types of labels of charging which are available, like slow, moderate, fast charging? It is also categorized as a level 1, level 2, level 3 or DC fast chargers. Next, layout of types of EV charging, charging technologies for electric vehicles, type of EV chargers and type of connectors, and finally, we will summarize this lecture. So, if we see the introduction, so the global transition to electric vehicles, it is playing a vital role for reducing the carbon emissions. So, suppose we have electric vehicles and it is charged through renewable energy like solar and wind, which could help to reduce the total carbon emission and greenhouse gases. EV charging technologies are crucial for widespread adoption of EVs. Like if you are able to charge these EV quickly, this will help to save the time and it will help to adopt these electric vehicles in very wide, we can say it will be adopted by customers. So, in this lecture we will cover type of charging, various standard for charging and overall architecture that are essential for EV charging system. So, if we see any electric vehicle batteries or charging system integrated with electric vehicle battery, initially it charges with constant current phase, rapidly charges the battery up to 80% of SOC, and as soon as battery reaches to 80%, the charging is switched from constant current to constant voltage phase, which will slow down the charging rate and it can be safe from overcharge and discharge. As the battery approaches full charge, its internal resistance increases. This makes it harder to push additional charge into the battery. A similar analogy can be given in an empty hall where the chance to find a seat to sit in relatively easier compared to the room that has 80% of seats are filled. So, if we take example of a cinema hall, it is easier to find out our seat when it is vacant. However, when it is full, it is very difficult or it is harder to go to the seat which is allotted to us. Same thing has happened to the battery. If battery is empty, it can be quickly charged, but these charges, when it is charged up to 80%, it is very hard to charge, find the place where they will settle down. So, in order to charge a battery, a DC-DC converter, before this DC-DC converter, a AC to DC converter is adopted, so that AC power can be converted into DC and the battery current can be regulated using these DC-DC converter, such as buck boost converter, dual active bridge converter. Normal buck boost converter, which is shown here, this is non-isolated converter. It comes under the category of non-isolated converter. There is no isolation between input and output. However, if we see dual active bridge converter, we could find out there is one isolation transformer. It is a high frequency isolation transformer, which is utilized to provide isolation between input and output. It is a very essential part of this converter, and here one of the converter is operating as an inverter unit. However, other converter it is operating as a rectifier, and it will depend which converter is operating as an inverter and which converter it is operating as a rectifier. It will depend on the power flow from input to output, we can say from the DC bus to battery, as well as it is from battery to the DC bus. So, these non-isolated converter topologies are employed for charging batteries where there is voltage range of 250 to 400 volt and isolations are required. And here we can see we have CCCV charging, where the current initially the magnitude of current is increasing, and after once the battery is charged to 80% of SOC, the current become constant. However, there is current decreases and then voltage become constant after this 80% of SOC. So, we have current state of EV charging technologies. Global EV sales double in 2021, reaching around 6.6 million units, and this international energy agencies, they have these stock global electric cars, and there is projections, it indicates a global EV fleet of 230 million by 2030. The deployment of charging infrastructure is key to supporting this growth. Without charging infrastructure, adoption of electric vehicles is very tough. We need to develop the charging infrastructure like a petrol pump, like our fossil fuel based pumps. In every 4 or 3 kilometers range, you could find out a refueling stations. So, according to this, this is the current status of EV charging technologies, where development of these which help to sales of these electric vehicles and others. So, layout of types of EV charging, here we can see the charging infrastructure, which can be distinguished in terms of speed of charging, fast charging, standardization of chargers, ownership, the process of charging, which kind of charging we are going to adopt, and power flow, directionality, either it is a vehicle to grid, grid to vehicle, the power is coming from the renewable sources or power is coming from the distribution grid. So, at the if we see the figure, we have EV charging infrastructure which is depending on majorly 5 factors. One is process, another is connector type, third one is power flow, use, charging speed. Now, if we take first point, process is categorized into two parts. The first one is bidirectional and unidirectional. If we talk about unidirectional charging, this vehicle to grid cannot be adopted in case of unidirectional charging. In case of unidirectional charging, we can only take power from the power grid, and people are utilizing diode bridge rectifier. It could be single phase or 3 phase. It is adopted to convert this AC electricity into DC, and further DC bus voltage and battery current can be regulated having this DC-DC converter. But most important thing, only one mode is possible in this case. We can draw the power from the electricity grid. The vehicle to grid mode is not possible in case of unidirectional charger. Various onboard chargers nowadays which is carried by 3-wheeler and 2-wheelers, 3-wheeler rickshaw and 2-wheeler these Ola scooters and other e-bikes, they are carrying this onboard charger which are unidirectional. They can take power from the grid, from the single phase socket, 3-phase socket, and this battery of 2-wheeler, 3-wheeler can be charged. But from the battery, from the EV battery, the power flow from the EV battery to the grid is not possible in this case. However, if we see the process, other side we have bidirectional. In case of bidirectional, both the operations are possible. Grid to vehicle, I mean we can send power from grid to vehicle battery, so that the battery can be charged, as well as in order to operate this particular system in battery to grid mode, we have to use bidirectional converter both the side, from AC to DC and then DC DC. Both the converters must support the bidirectional power flow. So, for this purpose, people are taking for AC to DC conversion, instead of diode bridge rectifier, people have adopted bidirectional converter, which is nothing but that is the 3-phase or single phase controlled converter, which could be which could use IGBT, MOSFET, depending on the power level. And nowadays people are also using silicon carbide and gallium nitride based devices, so that the size of the converter can be reduced. These devices can be fired at very high switching frequency. Other side, if you see the connector type, we have two types of connectors. One is AC charging type of connector, the other is DC type of charging connections. So, AC charging connections, it is categorized further as a type 1, type 2 and this CCS. Other side which supports the fast charging, DC charging, and it is categorized as a CHAdeMO, combined charging system CCS, and another for Tesla vehicle, these people have launched this Tesla supercharger. If you go to the third component, power flow. Power flow may be plug-in, where we have onboard charger, and these onboard charger directly can plug in at the AC socket. We may have DC fast charger, where the battery can be plug in or connected to the DC fast charging. We may have wireless charger, where one plate can be communicate with the other plate for wireless charging, like a capacitor, one plate of capacitor with the vehicle and another plate of the capacitor with the charging station, and they may interact wirelessly to charge these vehicle. Other side we have battery swapping. So, charged battery can be swapped with the empty one, which is along with the vehicle, and charged battery can be integrated or can be put in the vehicle to move further. Then we have use. So, these charging stations are developed as a private charging, like home charging, and other are public charging, semi public charging. So, public charging must be fast charging. It could also include these AC chargers, but it must support these DC fast charging. Now, charging speed, we have slow, medium, fast. So, slow charging is integrated with the home charging, medium and fast charging, they are integrated with the public charging. So, here the charging speed is very crucial for adoption of electric vehicle. Charging speed is crucial for charging infrastructure because of the factor like user convenience and experience, infrastructure utilization, range anxiety reduction, grid management, we can say energy management system, power management system, technical compatibility. So, these are the factors which are playing a crucial role in the charging speed. Three types, or we can say three typical categories of charging speed exist in practice: slow, fast and rapid. For rapid charging, vehicle manufacturers primarily use three type of vehicle side sockets. However, type 2 connectors, 43 kilowatt 3 phase output and 2 DC connectors as named CHAdeMO, which is usually 50 kilowatt output, but nowadays this CHAdeMO as well as DC fast charger, they are supporting up to 350 kilowatt, and this we have other CCS combined charging systems. This schematic structure of type 2 connector, which is widely used for both AC and DC charging in both infrastructure and vehicle. The two rapid connectors CHAdeMO and CCS are presented here, and these 2 pin in the bottom row facilitate 3 phase AC connector. The connector is capable of handling a current of 63 ampere. We will see this particular what are the pins which are integrated with the charger in the coming slides. So, here we have types of EV charger. So, as I told you, we have two type of EV charger, one is home charging and another is public charging. So, home charging, it is rated at 230 volt and 15 ampere. However, public charging, they have been categorized into two part, that is AC charger and DC fast charger. So, public charging also facilitates for normal AC as well as fast AC charging, because some of the e-rickshaw or two-wheeler vehicle owner can come to charge their vehicle from the normal charger or from the slow charger. So, this kind of facility must be provided by public charging station also. And the DC fast charging, they are categorized from 10 kilowatt to 50 kilowatt, but nowadays as I told you, this is categorized up to 350 kilowatt, where it can be categorized depending on the voltage level from level 1 DC charger and then level 2 DC charger. So, here we can see the different levels and modes of EV chargers. We have a specification as charging power, rating of charging power, charger type, locations, either it is a home based or public, charging time, and then power supply. It is also have supply interface and production type, and then finally standard. So, if we see this particular charging power, level 1 it is have this here it is mentioned up to 1.9, but if we talk about these charging power, it is up to 3.3 kilowatt. Level 2 we have up to 19.2 as it is shown here, and the level 3 it is rated from 20 kilowatt to 350 kilowatt. Nowadays people are also developing these extreme fast charging, which can facilitate charging more than 350 kilowatt. So, it is coming under the category of extreme fast charging. We have various chargers on board, which is also known as slow charging, on board semi fast charging, and private fast charging, off board fast charging, off board ultra fast charge. So, extreme fast charging is coming under the category of ultra fast chargers. Charge locations: residential, private and commercial. Level 3 can be used for commercial purpose, and extreme fast charging is also applicable for commercial purposes. Charging time: this level 1 can take, if you need 200 kilometers, it can take 20 hours charging. For 200 kilometer range, 5 hours from the level 2. For same range, level 3 can provide charging within 30 minutes. And if we talk about extreme fast charging, approximately 5 minutes with high energy density of 1000 VDC, the DC bus voltage with the 1000 volt, so that a large amount of power can be provided, and the magnitude of current, huge magnitude of current can be injected to the battery, so that it can quickly charge. We have different power supply over here. Supply interface and protection type. So, protection is essential in case of all the charges, but protection become mandatory in case of level 3, level 2 as well as extreme fast charging. Dedicated EV supply equipment, breaker in the cable and pilot function, dedicated EV supply equipment, communication and event monitoring between EV and charging station. So, here we have various standards for level 1, level 2, level 3 and level 4. So, we have SAE, Society of Automotive Engineers J1772, IEC 62196. So, they have different standard as per the protection, they have a standard for this battery rating depending on the level 1, level 2, level 3, they have given these standard. So, if we see the overview of charging methods and topology, they are categorized into conductive charging, which is a physical connection is mandatory, inductive charging, which is also known as wireless, where the energy is transferred from one point to another using electromagnetic induction. Third one is battery swapping, where depleted battery can be replaced with the fully charged one. Charging topologies, we have onboard charger and offboard charger. As I told you, onboard charger, it is integrated with the vehicles, or we have to carry this onboard charger with the vehicle. Offboard charger, it is situated in public places, located outside the vehicle, and it can support fast charging. So, charging technologies for electric vehicles, as we have categorized. So, here I am showing charging technologies. It has been categorized into 3 part: conductive, where we need to have physical connection, wireless, and then battery swapping. So, electric vehicle charger have evolved over the year. Presently, various type of charger are available in the market to serve different categories of EVs. Electric vehicle charging can be classified into different types, which can be see from this categorization. Based on the technology use of charging, it is classified into 3 types. And further, conductive is classified as a off-board, on-board, and then wireless can be classified as a inductive and capacitive. So, this is the conductive charging, where we have different component. We can consider different sources like grid, solar energy, and then we can also consider battery energy storage at the charging station. We have onboard charging and off-board charging. So, in case of onboard charging, this AC to DC and DC DC conversion unit is along with the onboard charger, and generally in case of 4-wheeler, it is integrated with the vehicle. However, in some of the 2-wheeler and 3-wheeler, you will find out it is carried with the vehicles. So, we can pull it out and we can connect with the socket of single phase or 3 phase as per requirement, as per the given number of supply phases in the charger as well as availability. We can charge our battery vehicles. One of the important thing here, battery management system is also integrated, which could communicate with the charger and EV battery, because protection point of view, how much current I have to inject to the battery, that information has to given to the charger. So, accordingly the current can be drawn from this charger. So, communication protocol, this battery management system are also important. The wired charging use either AC or DC power to charge the EV from electric vehicle supply equipment. The wired EV chargers can be either on board or off board depending on whether the charger is within the EV or in the EVCS. In the case of onboard charger, the AC power is supplied to the onboard converter, which then converted into DC to feed it to the battery. However, in the off-board charger, the converters are the part of EVCS, electric vehicle supply. The wired charging use either AC or DC power to charge the EV from electric vehicle supply equipment. The wired EV chargers can be either on board or off board depending on whether the charger is within the EV or in the EVCS. In the case of onboard charger, the AC power is supplied to the onboard converter, which then convert it into DC to feed it to the battery. However, in the off-board charger, the converters are the part of EVCS, electric vehicle supply equipment, and directly supply the DC power to the EV battery by bypassing the on-board charger unit. Hence they can charge the battery at a faster rate. So, type of EV charger: on-board, off-board. It is a on-board charger, it is a slow charger, and the basic component of on-board charger, we have rectifier which converts AC to DC. It could be uncontrolled and controlled converter, where people are using IGBT and MOSFET. However, uncontrolled, people are using Dart bridge rectifier, but there are significant harmonic which are appearing at the AC side if you are using uncontrolled rectifier, because our loads are classified into two part: step current and step voltage. We can say constant current type of load and constant voltage type of load. Most of the charger, most of these rectifiers, they have this what we call capacitor at the output side. So, they are categorized into constant voltage type of load, and they draw peaky current from the source. So, a power factor correction unit is very essential, and it ensures the efficient power use, and it can reduce the losses at the supply side. We have another unit which is categorized as a DC-DC converters, and it helps in regulating the DC bus voltage as well as the current which is injected to the battery. The third and integral part of this device is communication interface, which allow the charger to communicate with the vehicle's BMS for safe and optimized operation. So, this is the configuration of an onboard charger. Here we have AC charging station, AC controller, we have various safety interlocks, AC supply. This AC is going to convert it into DC, this rectifier, then DC-DC converters. This DC converter may have this DC-DC converter is used to regulate the DC bus and battery current. Then we may have production circuit, then battery management system communicate. This BMS communicates with the power control unit and production circuits, and accordingly it will provide this charger will provide the current and power to this EV battery. So, this is the dedicated onboard charger. Configuration of dedicated onboard charger, it includes various AC-DC and DC-DC converter. EMI filter is also essential part of this onboard charger. Now, off-board charger are external charging units that are not integrated into electric vehicles, but they are located outside the vehicles. They are commonly used for fast charging applications and are found at public places. This type of charger is not within the vehicle, and the charging unit like AC-DC converter, it is installed in public places. So, they can provide fast DC charging as well as they can deliver very high power to the battery, and it is rated from 50 kilowatt to 350 kilowatt. So, these are the few configurations of off-board charger, where other companies like ABB, they have developed these Tera 50 kilowatt charger and 150 kilowatt charger with high power rating. So, here I have given some example which could realize, one can realize the DC off-board charger, what are the internal configurations, what are the power electronics which are utilized for these charging stations. Types of off-board charger, they are coming under level 3 categories. Components, we have power converter. Cooling system is very essential. We have These because these chargers are rated at very high power. So, a significant cooling is required when these chargers are in operation, and they require robust cooling system to maintain safe operation, safe operating temperature. We can say temperature must be within the range, otherwise it may caught fire and other issues may come into the picture. Communication interface ensure proper communication between the charger and the vehicle battery. User interface typically includes a touch screen or button for user to initiate the monitor the charging process as well as payment system. Here you can find out the various type of connectors, CCS, US Europe, CHAdeMO, then Tesla and other China made this GBT standard. So, in different company people are using different type of connectors also. We have two type of charging point, floor mounted, which is basically DC charger, and then other side we have wall mounted, which could be level 1 or level 2 charger. We have different comparison of charging modes and then different standards. So, we have conductive charging coupling for EV, which is given by SAE J1772. We have other IEC standard, ISO standard for safety, power quality and communication protocol. So, every standard we have given along with their descriptions, and then categorization of unidirectional and bidirectional power flow, how grid to vehicle and vehicle to grid is taking place. Types of connectors. So, we have AC type and DC type. Here we have different types of connectors and different pins we have given. So, initially we can see these are the two chargers which can provide facility of AC as well as for DC charging. So, thank you for participating in today's lecture, which is based on current state of EV charging technologies, what are the levels of charging, modes and type of charging. We have explored different type of charging systems, what are the types of connectors, what are the operating modes, and what are the various connectors which has been launched by different companies. I hope this session has provided you with valuable insights and deeper understanding. Looking forward to seeing you in our next session. Have a great time, keep learning. Thank you very much. These are the few references which could follow to see these content, and you can go through these references to explore further. Thank you very much.